Yo guys, what's up? Today we're going to be talking about parametric curves and parametric equations. Um, Essentially, all a parametric equation is it's basically just your y's and your x coordinates are defined by a curve. So you could have the parametric equation of like y equals x squared and x equals or y equals like t squared and x equals like t plus 1 squared, and you would just plug in values of t into both those equations, and your x value would be whatever your x is equal to. Your x equals, like for example, looking at this first problem, um, it would be like x. If I had 1 for t, my x coordinate would be square root of 2 because I plug in 1, and then this is x, and then my y coordinate would be 1 half because it's 1 over 1 plus 1. So my full coordinate would be square root of 2 1 half. That's essentially all that they are. It's just instead of defining your coordinates as one line, you're defining them by two lines and then finding, whatever it is. Um, they ask you to find with that. So that's one thing. A good example of parametric equations are sine, or is the unit circle essentially. Um, Cosine x and sine x. Okay, so when you have a unit circle, you have, it's really bad. That's also really terrible. You have like this, and then this is like 1 0. This is 0 1. This is negative 1 0, and this is 0 negative 1. So looking at this, these coordinates right here are defined by whatever your cosine value is at that, and whatever your sine value is at that, whatever point, at whatever angle, or whatever angle. Um, so that's essentially like a really good way to think about it. It's not defined by, like, if it was defined by just sine x, it wouldn't be this unit circle. It would just be a sine wave. If it was defined by cosine x, it would just be a cosine wave. But since each individual coordinate is defined by its own function, then that's what makes it a parametric equation in a sense. So yeah, all parametric equations are is when the coordinates are defined by uh, individual functions that aren't the same function. If they were the same function, it would not be a parametric equation. So looking at this first problem, eliminate the parameters. What that essentially means is you want to get this in terms of x and y, and essentially just take out t. You don't want to have a t. So if you remember like algebra 1 or 2, essentially like substitution, where you find if you have like a variable that you don't know, but you have like an equation that you do know that also includes that variable, you set one of the equations equal to the variable you want, and then plug whatever you get in for the other variable. Okay, so like watch this. So I see that I want to get t equals something, so I can plug in t over, so I can plug whatever t equaled in for t and get a y equals and take out t over here. Um, so that's what I'm gonna do. To get rid of the square root, I need x squared, and then to get it, so it's x squared equals t plus 1, uh, and then this to get it just equal to t, it's x squared minus 1 equals t. And then all I have to do, I forget what t was equal, I just plug it in for y. I just plug it in over here. So y equals 1 over x squared plus or minus 1 plus 1. So you see what I did. I set it to equal to t, and then I just plugged in what I got what my x value over here was for t. So this is just 1 over x squared equals y. And this is your answer. This is how you eliminate parameters. You take out the t by setting one of the equations equal to t and then substituting that in. Okay, so now we have the next problem. Find the equation of a tangent line at pi over 6 for the parametric function, and then this. Okay, so what we do here is we need to get a tangent line, we need a point and a slope. The slope we don't have right now, and the point, well, we have an x coordinate. We own well a t coordinate technically. We have pi over 6. So if we want to get the coordinate first, we would just simply plug pi over 6 into this. So let me do that real quick. Let me open up a calculator. So, 1 second. So to do this, so yeah, we're just gonna plug in our 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 point essentially, our t value of pi over 6, because it's at pi over 6, in for this. So this is equal to 2.58, 2.589 for our x value. And then our y value is, let me check, 1.5. Okay. And now slope. So with this, to find our slope, your slope is dy dx always. Um, it's not going to be dy dt, because if it was dy dt, that would only be this essentially. It would only be this. Um, it wouldn't even bother with the x, because this is dx dt. This is dy dt. So we need both of them, because it's our rate of change in our y coordinate over the rate of change in our x coordinate. So to do that, it's just dy dx is equal to dy dt over dx dt. This is a formula that you have to memorize. Um, it's really not that bad. It's kind of logical, because this dy dt is just the okay. So dx dt is the rate of change in your height over the rate of change in your slope, otherwise known as, or in your x coordinate, otherwise known as rise over run. So since in this instance we have our rise and our run determined by functions, we need to determine the derivatives of those functions and then put them over each other. Okay? So this is equal to 3 cosine t over negative 3 sine t, which these cancel out, and this is just cotangent t. Okay? Or negative cotangent t. And personally, just because cotangent isn't on a calculator, I would just plug in, um, I would just straight up just plug in pi over 6 before I even bothered with I wouldn't even, I wouldn't even put it as cotangent t. So I'm just gonna cross it out, because you can't put cotangent t into a calculator without just doing this. So it's just gonna be negative cosine t over sine t. And since we want to find it at pi over 6, we just plug in pi over 6 for these. So let me get a calculator for that. Negative cosine pi over 6 divided by sine pi over 6. This is equal to negative 1.73. Okay, so now we have a slope and a point. So that all we have to do is just use point slope form and just plug in our values. So we might say a different color. Okay. So we know that this is our point. So we're just gonna do y minus 1.5 is equal to negative 1.73 times x minus 2.59. And this is our answer. You don't have to move it and make it y equals. You don't have to do that. You could just leave it as this. So yeah. Okay. And then moving on to another like sort of formulaic problem that you'll have to do on pretty much any exams with parametrics, on any calculus exam with parametrics at least. Um, Find the length of the curve. So um there are two formulas for this to do this. One is like it depends on the form in which they give it to you. If they give you two individual like x equals t something and y equals t something, then you're gonna use the one that I'm about to use. If they give it to you in the form of like y equals like x to the 3/2 or y equals like x to the squared plus 3x or whatever, and you want to find what this is equal to, what the length of the curve is, you use a different formula. I'll just write the other formula at the end of this video, just because I don't want to A, I don't want to confuse anybody, and B, it's not relevant to the problem. Okay, so getting started with this formula, all it is integral from b to a of dx dt squared plus, this is square root, my bad, all under a square root, plus dy dt squared dt. Okay, so your derivative, your y is always, well, I guess it doesn't matter because it's plus here. But if your y was like negative, if you got a negative derivative of y, then your y would go second and your dx goes first. It's like distance formula essentially, except it's under an integral. That's really it. It's distance formula with the derivative instead of your x1 minus x2, and it's in an integral. That's the only difference. So that's kind of where they derived this formula. Um, is just from standard distance formula. Okay, so now we're just gonna straight up solve this. So dx dt is, oh, and I forget to write down where it came from. Let me get it. In the problem they'll give you your yeah, they'll give you your what is it? Uh your b and your a, your interval. At least normally they will. So your interval here is 1, 2. Okay, so well, t equals 1 and t equals 2. So there's that. Um, Another thing that they might do is give you like 2 points, like an ordered pair, like I don't know, from like 3, 4 to 5, 6, and then all you would need to do is just do like a distance formula between the two, and yeah, that's pretty much it. It's those ones really aren't that bad. Um, Actually, no, you wouldn't. My bad. You would plug in if they gave you like, okay, so let's say they gave you 1, 1 and 4, 8, for example. All you would do is you would set your y in this instance. You would set one of these equal to, you would set your second one equal to y, or your y terms equal to y, and so it would be a equals t cubed, and then you would solve for t, which in this instance would be 2, and x, you would set x equal to, or not x, but 1 equal to t squared, and t is just 1. So that would be how you would solve them if you did them that way. Is you would just set your coordinates equal to the thing. You could also, you don't even have to set, you set one or the other as well. You don't have to set both. Like for example, if I could just set y, so I could just use the y and do you know, uh, 1 equal to t cubed, which is just 1, and then 8 equals to t cubed. You see I went from 1 to 8 is just 2. So that's how you get your interval from this, your boundaries. So it's sometimes they'll give them to you just straight up. Sometimes they'll give you a point, but with the point, that's just how you solve it. It's not too terrible. It's pretty common sense. So 1, 2, of square root of dx dt squared. In this instance, that's just 2t squared plus 3t squared. It's 3t squared squared dt. This is integral from 2, 1 of this times 4t squared plus 9t to the fourth dt, which this is just, you can take a t outside, so you get 2, 1t of 4 plus 9t squared dt. And then here you can do a u sub. I'm going to have to write further to the right of this. 4 plus 9t squared, which is going to give you integral of 2, 1 times, what's this? Is that going to be 1 over 18? 1 over 18. Because you see du is equal to 18t, and we only have 18t, and we only have a t, so we need to times it by 1 over 18 on the outside of square root of u du. And then now we're just working with this, which is this is equal to 1 over 27. Let me do this real quick. U to the 1/2, so u 3/2 times 2/3. Okay, so now we're doing this times 1 over 18. So this is just 1 over 27 of u. Yeah, I put my 2. I just changed my I plugged my 2 into here and got 40, and then I plugged my 1 into there and got 13. So I redefined my uh, thing, my boundaries. So it's this is going to be equal to this 40, 13 square root of u du is equal to 1 over 27 of u of no 40 3/2. You see, now I'm plugging 40 into here, plus, or no, minus, because yeah, minus 3/2, and this is just let me just write it up here. This is your answer. So I mean, this problem was a little bit more tricky than the others, just because you had to do u substitution. Usually once you break it down to this stage or this stage, it gets really easy. But yeah, this one was a little bit more demanding, because not only did we have to factor out t, but we also had to use u substitution just to solve the integral. And then even past that, plugging in these boundaries with this fraction on the outside was pretty difficult. The formula that you're gonna want to use for when they give, more often than not, when they do arc length, they give you it in terms of y equals x something. You rarely ever have to use that other formula, but here's the formula that you'll usually have to use for arc length. BA of square root of 1 plus dy dx squared And so say that they give you like something like x to the 3 halves. You take the derivative, plug it in here, square it, and then solve this integral. It's this is a lot easier to do, and generally you're gonna get, generally just speaking from experience, you end up getting like a -1 or something on the side that cancels out the one, um, and then you just you factor out stuff with a square root, and you know you just solve an integral. So this is more often than not the sort of arc length thing that you're going to be looking at. So yeah, that's pretty much it. I